Okay, practice with multiply and dividing rational expressions, day 1. So simplifying state restrictions on the variables. So when we multiply two fractions, we are going to multiply the numerators and then multiply the denominators. Okay, so we're going to multiply y squared times 8, so we get 8y squared. And we're going to multiply 3 times y, so we get 3y. So before canceling anything out, we can state the restriction. Y does not equal 0 because we have y in a monomial in the bottom, okay, in the denominator. Now, this squared and this y cancel out, and we're left with 8y over 3. Okay, for b, we multiply the numerators, so negative 7x to the 4 divided by, and we're going to get 14 times 2 is 28x to the 3. Okay, so x does not equal 0. Oh, I should have put that here for the final. So x does not equal 0 because x is part of a monomial in the denominator. Okay, and if we divide negative 7 divided by 28, we get 1/4, negative 1/4. I'm not going to write the 1 here because we're still going to have a number in the numerator, so writing the 1 is like redundant. So x cubed cancels with the 4. So negative x over 4 such that x does not equal 0. Okay, and then C. This time we have a division. So what we want to do is we want to, first I'm going to write any restriction that this question has. So right now in the denominator, y does not equal 0. So I'm going to rewrite this entire question, but instead of division, I'm going to write multiplication. And I'm going to do it as a dot because we have x's in here. And we're going to multiply by the reciprocal. So 32y cubed over 9x. Now that the x is introduced into the denominator, we have another restriction. X does not equal 0. Okay, and now we can actually multiply. So we're going to multiply the numerators. I get 288 xy cubed. And the denominators, I get 36 xy. Okay, so the x's cancel out. The y cancels with the 3, and the 3 just reduces by 1. And 288 divides by 36, and that gives us 8. We're left with 8y squared, such that y does not equal 0, and x does not equal 0. Okay, D. So the numerators, 3 times 8 is 24, and we have x cubed y squared, and that's going to be over 18, x to the 9y. So before I cancel anything out, x does not equal 0, and y does not equal 0, because they're part of this monomial in the denominator. Okay, so 24 divided by 18, I get 4 over 3. Okay, so I have x cubed in the numerator, x to the 9. So these are going to cancel, and the 9 is going to go to a 6 in the denominator. Okay, this y is going to cancel with the squared, and we'll still have a y in the numerator. And then we always want to follow that with the restrictions. There we go. Okay, so this time, same multiplication, 21 times 12, we get 252. Okay, and then we get x, y to the 5. Okay, and then we have 7 times 4, which gives us 28. And we have x squared, and we have y squared and y cubed, so we'll get y to the 5. Okay, so 252 xy to the 5 over 28, x squared y to the 5. Okay, our restrictions are x does not equal 0 and y does not equal 0. So 252 divided by 28, we get 9. Okay, this x cancels with the squared, and we get an x in the denominator, and the y to the 5s just cancel. So here we go. We're left with 9 over x such that x does not equal 0, y does not equal 0. Okay, this time we're doing a division. So this is going to be over 1. So right now, a and b cannot equal 0. And I'm going to rewrite the entire equation. So the first fraction I'm going to rewrite as is. And now I'm going to multiply by the reciprocal. So a little tedious to put the 6c squared over 1, but it's needed sometimes when you want to take a look at the reciprocal. Okay, flipping this introduced c in the denominator, so now we have another restriction. And all we're going to do is collect everything and then divide it out. So we have 4a squared b cubed c over negative 18ab c squared. So 4 over 18 cancels to negative 2 over 9. Remember, this negative sign comes into the numerator when we simplify. This squared and this a cancel. We have an a left on the top. This cubed goes down to squared, and this cancels, and we're left with b squared in the numerator. And this c and this squared cancel. We're left with c in the denominator. And we do such that a does not equal 0, b does not equal 0, c does not equal 0. Okay, so this one's division as well. So first I'm going to state the restrictions in the denominator. X does not equal 0, y does not equal 0. And now I'm going to rewrite the first fraction as it is. And I'm going to multiply by the reciprocal. So in the numerator, 5xy 4. And in the denominator, 7x squared y 6. Okay, now I just introduced this monomial into the denominator, but we already have restrictions on it, so we're good. Okay, 28 times 5 is 140. X cubed x to the 1, we get x to the 4, and then we get y to the 5, right? 1 plus 4. 15 times 7 is 105. We get x cubed and y to the 7. Okay, so if we divide 140 divided by 105, we get 4 over 3. Those cancel to an x in the numerator, and then that cancels to y squared in the denominator. And then we always want to put the restrictions in our last step. So 4x over 3y squared, such that x does not equal 0 and y does not equal 0. Okay, number 2, simplify and state restrictions on the variable. Okay, now we're getting into binomials. So a lot of times what I like to do is I like to bracket the binomials in order to just organize my thinking. Okay, so this is multiplication still. I'm going to put the monomial in front, so 10x, and then I'm going to follow that by bracketed x plus 3. You have to bracket the x plus 3. You can't just put a multiplication symbol here because it's going to look as though it's just on the x if you don't have the brackets, okay? But that 10x is multiplied by both. Okay, and in the denominator, 5x, x plus 3. Okay, so before we cancel anything out, x is in a monomial, so x does not equal 0. Okay, and then x is in this bracket, and we know that x plus 3 cannot equal 0, so x cannot equal negative 3. So we have 2 restrictions. Now I'm going to cancel these, I'm going to cancel this, 10 divided by 5 is 2. So our simplified version is 2, such that x does not equal 0 and x does not equal negative 3. Okay, I'm going to do the same thing for b. I'm going to bracket the binomials. Okay, and right now there are no variables in the denominator, so no restrictions so far. I'm going to write the first term as it is, and then I'm going to multiply it instead of division, and I'm going to take the reciprocal of the second number. Okay, now that I've introduced n minus 6 into the denominator, we have a new restriction, n does not equal 6. If we were to plug the 6 in here, 6 minus 6 is 0, and we can't have that. So, pull the monomials in front for better math form. We have 27, m plus 2, 9, n minus 6. These brackets cannot cancel. These numbers can reduce to a 3. So 3 is going to be in the numerator, such that n does not equal 6. Okay, so m bracketed m plus 2 over n minus 6, such that n does not equal 6. Okay, and for C, again, bracket all the binomials. Such a good habit to get into. Immediately I see that x cannot equal -3. Both of these denominators are the same, but they're about to switch. So we have division. So what we want to do is keep the first fraction the same. We want to multiply by the reciprocal. Okay, this has introduced x minus 7 into the denominator, so a new restriction. X does not equal 7. Okay, so now we have two restrictions. You can technically write these beside each other. Since they're all bracketed, I don't find that necessary. I feel like I can just cancel them out, and they cancel out to 1. 1 such that x does not equal -3 or 7. And because we're just talking about x, we can list them with a comma. Okay, so D. We have multiplication here. I'm going to bracket the y plus 1s. Okay, so I'm just going to put these all together. 5, y minus 2, y plus 1, over, I'm going to bring the 10 out front. I personally like the monomials out front. It's easier to read. Okay, so the restriction already is y cannot equal -1. These cancel. 5 over 10 cancels to having like 1/2, so the 2's in the denominator, and we're left with y minus 2 over 2, such that y does not equal -1. Okay, so this is a division one. So I'm going to bracket these and these. So 7t minus 7, we can actually factor out a 7. That's just a common factor. Okay, and left in the bracket would be t minus 1. We can leave the 4t there. However, we're going to multiply by the reciprocal. So 16t to the 4 comes to the numerator. And in the denominator, I'm going to also factor out just a 2. So 2 bracket t minus 1. Okay, at this point, we have two restrictions. I'm going to put them down here just for spacing. T does not equal 0, right, from the monomials, from the original, and t does not equal 1 from this t minus 1 bracket. Okay, so we're going to go 7 times 16, and then we'll do t4. So 112, t to the exponent 4, t minus 1, and that's all going to be over 8t, t minus 1. Okay, at this point, I'm going to cross out the t minus 1s. This 4 goes to a 3, and the 112 divides by 8, it's 14. So I get 14 t to the 3, such that t does not equal 0 or 1. Okay, for f, we have 2m minus 1 over n cubed, and then this is multiplied by 15n over 6m minus 3. So the 6m minus 3, I'm going to common factor out a 3. I'm going to put 2m minus 1 in brackets, and I'm going to move this 15n in front as the monomial. Okay, so I get 15n, 2m minus 1 over n cubed. I'm going to factor out a 3. So I'm going to put that as the monomial, and then 2m minus 1. Okay, so the restrictions here, n cannot equal 3 or 0, and m cannot equal 1 over 2. Those go away. 1 of the n cancels, so we have n squared in the denominator, and then 15 divided by 3 is 5. Okay, so we have 5 over n squared such that n does not equal 0, m does not equal a half. Okay, so we have g. This first expression, I'm going to factor out 3x. So I get 3x, x minus 2. And on the bottom, I'm going to factor out a 4. So I get 4x plus 5. And this is going to be divided by, I'm going to factor out a 3x here. No, 9x. 9x, x minus 3. And then that's all over, it's x minus 2. And that's all over, I'm going to factor out a 3, 3x plus 5. Okay, so I'm going to list the restrictions right now because then I'm going to flip this and multiply. So x does not equal negative 5. And that's it so far. Okay, so I'm going to rewrite this entire thing. Like the bracket there. 3x, x minus 2 over 4x plus 5 multiplied by, and then we're going to take the reciprocal, 3x plus 5 over 9x, x minus 2. We have just introduced these two restrictions into the denominator, so 0 and 2. Now we can start crossing out. So x minus 2's go away, x plus 5's go away. The x's go away. And if you think about this, like 3 times 3 is 9 over 36, which cancels back to 1 over 4. So our answer is 1 over 4 such that x does not equal negative 5, 0, or 2. Okay, same thing for h. I'm going to factor out a, here you go, factor out a 2 here. The denominator here I'm going to leave. I'm going to factor out a 2 here. And then this denominator I'm going to switch. Okay, so I have 2x squared minus 5 all over x plus 3y times 2x squared minus 9y squared all over, I'm going to go negative 6x squared plus 15. Okay, in this one, I'm going to factor out a negative 3, and this one's actually difference of squares. So I'm going to rewrite this first rational as it is. Okay, then I'm going to write the 2, but this is difference of squares. So we can root x squared, we get x, and we can root 9y squared, we get 3y. So our two brackets are x plus 3y, x minus 3y. And that's all over negative 3 bracket 2x minus 5. Okay, to this point we have two restrictions. We have x does not equal, right? Bring that over, negative 3y, and x does not equal 5 over 2. Root 5 over 2. Okay, we can cancel those out. X plus 3y, we can cancel those out. We're left with 4. X minus 3y, all over negative 3, and that's it. Okay, just as an aside, how to do that restriction on the denominator. If we have this restriction, we want to say 2x squared minus 5 cannot equal 0. We bring over the 5. 2x squared cannot equal 5. Divide by 2. Okay, so we have x squared cannot equal 5 over 2. We want to root both sides. So x cannot equal plus minus 5 over 2. Okay, just to write this neatly, we have 4x minus 3y over negative 3 such that x does not equal negative 3y and plus minus 5 over 2, root 5 over 2.